online lecture series for computer organization and architecture. Myself Dr. Inderjit Kaur, Associate Professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, after covering the different kinds of instructions and instruction format in the previous lecture, we will be discussing the instruction cycle in this lecture. So, before starting the instruction cycle that comprises of fetch, decode and execute, let us discuss first the basic computer control unit structure. So, the control unit of a processor, it is the heart of a processor, and the task of control unit is to convert the machine instructions to the control signals for micro operations that can be implemented. So, this control unit, it can be implemented in two ways. One is using hardwired control and another is using micro programmed control. When we are saying hardwired control, as the name suggests, the control unit will be comprising of too many wires, means it will be made up of different sequential and combinational circuits, so that the control signals can be generated. The task of control unit is to generate the control signal. These control signal means which operation I need to perform. So, that means the instructions, that the code that the program that the programmer is writing, the output of this program should be the control signals, so that the system, the control unit can understand what it has to perform. The ALU is giving the data ki on this data this operation has to be performed. So, when I am saying this, I am saying through speaking and you are understanding it while listening. How does the system understand ki this means addition, this means subtraction, this means circular shift left, circular shift right. So, it has to be trained in a way. So, how they are being trained and how the CU understands, that is it understands it when it implements and understands those control signals. So, the sequential and combinational circuit means either we are using the different logic gates or flip flops or through registers, decoders, in which either we are considering only the time or not the feedback only, or through present input or through the past output, whatever is the case. And the second type of the control unit, it is defined as the micro programmed control unit. Micro programmed means we are writing a control program, we means as a developer. So, the control memory on the processor, it is consisting of micro programs, that is the basic difference. So, when a circuit has to change, in this the circuit, complete circuit needs to change if I want some changes in my logic for designing my control unit, and in this the designer has to change the micro program only. So, changing the micro program will be much easier, but if we compare the speed, then the speed on writing through the hardwired control, it will be easier. So, the control memory on the processor, it contains the micro programs that activates the necessary control signal. That is the basic output to generate the control signals basically, and these control signals, they can be generated using two ways. Then, how to define the different components? As I said ki control unit, it is controlling all the parts of my computer system. So, it manages the four basic operations of my fetch, decode and execute cycle. Fetch means get the next program commands from the computer memory. As I said ki when a program it requires execution, that means it needs to be stored into the memory, so that then and then it can be executed. So, for execution it should be fetched from the system memory. Fetching starts from the first address, then to the next address, then to the next address till the program ends up, until and unless there comes a priority interrupt key to handle me first, then the current instruction address will be saved somewhere and then it will be resumed back after execution of that high priority interrupt. Then the second thing is decode. Decode means deciphers what program is telling my system to do. Then the third is execute, means carried out the requested action has to be done in execute. After then storing comes. Storing means I am saving the result to a register or memory. Then arithmetic logic unit means I am performing arithmetic or logical operations, and registers, they are being used for saving the frequently used instructions and data. This is my control unit of a basic computer. Here I am having the IR, that is consisting of 16 bits. We have discussed this instruction format in the previous lecture. In this we have said ki this is my address part, this is my opcode part, and this is my mode part. So, this address part is directly given to my combinational control logic. Then this 12, 13, 14 bit, that is the opcode, that is given to 3:8 decoder, and this decoder, it generates these signals D0 to D7. They are being given as the input to my control logic. Then the I, that can either be 0 or 1, that is a flip flop basically, that is given to again this the input for my combinational control logic that I am using. Here I am using two decoders. One decoder we have discussed ki one decoder I am using in OPR, opcode part, and the second decoder that I am using in through my 4-bit sequence counter I have used. So, that this sequence counter, it will be moving through the clock, either it will get incremented or it will be cleared after 15, means if I am starting from 0 to 15 clock cycle. So, after 15 it will again come back to 0, or in between if the instruction gets executed completely, then we will be restarting it, means it will be cleared to 0, and for the second instruction it will be started and then incremented and so on. So, the maximum I am taking, assuming that an instruction when it is executing, it can take maximum of 16 clock cycles. So, this 4-bit sequence counter output is given to serve as the input of my 4:16 decoder, here it is shown, and these T0 to T15 timing signals, they are generated. These timing signal along with address and the decoder output and the flip flop address and other inputs, if required, they are combinedly given to this combinational control logic. And what is the output that I am getting? The output from this combinational circuit I am getting is the control signal, that is how my execution of instruction is occurring. These control signals, they are basically understood by my CPU, and it performs actually the desired action that the user wants to do. Then as we said, this is my clock, it is moving here at T0, then at T1, T2, T3, T4. At T0, suppose in the starting this clear is cleared to 0, then at T0 when it is for one cycle, it gets cleared to 0. So, this moves on. At T1 for the next clock cycle, this comes, at T2 it comes on this, and at T3, at T4 and go and so on. Suppose at D3 I have given this and I do D3 T4, suppose I calculate this D3 T4, then the AND of this, it will set this to 0 again, and this will be the output D3 T4 I will get. Then in the basic computer, a machine instruction, it is executed in the following cycle, that is fetch an instruction from the memory, decode the instruction, then third step, read the effective address from the memory, if the instruction is an indirect address it is using, and the fourth step it is execute the instruction. If I am using the direct address means in the mode field suppose I have 0, then this third step is omitted, means the decoding of instruction, and at T3 the execution of instruction starts. And if the mode is 1, that is I am using the indirect addressing mode, in that case the effective address is being calculated at T3, and during T4 onwards the execution of instructions starts. So, upon the completion of step 4, the control goes back to my step first to do the fetch, decode and execute the next instruction for the second instruction. Similarly, at reaching at second instruction and I move on to the first step for my third instruction. So, this loop continuously goes on until a halt instruction has been encountered. So, this is my fetch and decode has been explained. This is my memory unit, and these here all are the processor registers. They are being connected to my common bus that has been discussed in the previous lecture. So, where here we want to give the focus ki at T0, the first step, here I am having the instruction program counter that is telling me the which address has to get fetched now. So, from PC I am moving on to AR, address register. So, how this will happen? The contents of PC will be placed onto the bus, and when I am saying the contents of PC they are placed onto the bus, it should have value 0 1 0. That means, in the second step it will move check the value of selection buses as S2, S1, S0 as 0 1 0. Then in the third step, so this I have told it will happen in the 2 step, means the PC it will be placed on the bus, and then from the bus the content will move on to the AR. When AR it activates its load input. So, this basically it happens in these 2 steps. This is one of my register transfers. I am transferring the content of one register to another register, and how this transfer occurs? This transfer occurs when I am placing the content of PC onto the bus, and from bus they are communicating, they are getting the value into AR. When AR is ready, means its load input is active. Then at T1 I am enabling the read input of my memory, so that my memory is now in a condition to read. Then first step I am enabling the read input. Then read is enabled. Then in the second step M of AR contents they are being placed onto the bus. In the third step, from the bus they are being placed onto the IR by enabling the IR as 101. Here it was 0 load input being enabled. Then after then the PC is being incremented by 1. So, this is T0 and T1, this is my fetch, how my instruction fetch occurs. After then I move on to the decoding part, means I read my whole of IR. Now I am with IR actually. We can see now I am with IR ready. This is how from PC I started with IR. Now this IR, as I know, it is divided into 3 parts. So in the decoding I will be decoding these 3 parts. We can see I have studied first the IR 15th bit, that is an I. Then I have read this IR 12 bits that are forming my AR, and then I am decoding my 12 to 14 bit, they are serving as my opcode. They are given to 3:8 decoder. We have seen in the previous slide, just previous slide, how these opcode they are being given to 3:8 decoder. So, this is how my fetch and decode is occurring. So, let us understand this flow chart that will give us a more clear picture how my different kinds of instructions they are being executed. So, start. Initially my sequence counter is 0 at T0, we have discussed it. I am starting with PC, they are moved on into AR, that is occurring in 2 steps we have discussed. At T1, now I am with address register, I will read this address register from my memory and I will form my IR, and I will now increment my PC side by side so that the next instruction address I can know. So, this is my instruction fetch has been done. Now, at T2 what I am doing? I am just decoding my IR, that means I am reading my mode bit, I am forming my address register. Don't get confused this address register with the initial one. That initial one is giving you where we have to go, and this register it is giving you the operand register. The third field is IR 12 to 14 bits. Now, here the most common thing I have to see this D7. As I know it will be having 3 bits, these 3 bits they can be either from 000 to 111. So, if they are 000 to 110, that means they are memory reference instructions, and if they are this is 111, they are either register reference or input output reference. So, this D7 is deciding their criteria. So, if they are 0, so let us discuss this case first, memory reference. So, if D7 is other than 111 means it is either 000 to 110, we will say this is my I, we will now see our I bit. If it is 0, that means I am dealing with direct addressing mode. In direct addressing mode at T3 I will not do anything, and here if it is indirect I will just calculate my effective address, means M of AR I will access so that I can form my AR. Here after forming my effective address I will start execution of memory reference instruction at T4. And I will clear my sequence counter after this, so that the next instruction fetch, decode and execute can start. So, let us now discuss this left portion when my D7 bit is 1. So, if this D7 bit is 1, what does this mean? This means either my instruction is register reference or it is input output reference. Register reference means I am using one of the processor registers as the address, or I am giving input or I am getting the output. In that case I need to check this I bit. If this I bit means 15th bit of my IR, if it is 0, that is this is my register reference instruction, and this register reference instruction T3 I will start execution of this register reference instruction, and after this execution I will clear my sequence counter to 0. And if this is 1, that means this is my input output reference instruction, and at T3 I have to start the execution of input output reference instruction. So, here from the picture I can get a clear idea कि maximum of the instructions they are starting their execution at T3. If they are indirect, then at T4 the execution is starting. So, also one more important point, starting from execution at T4, it can continue till T15. After then the sequence counter will be cleared to 0 and I will be starting from T0, T1, T2 for the next instruction. So, this cycle continues for all the instructions residing in one program. So, now you can understand how complex is actually the execution for any control unit. Then starting from the register reference instruction. The register reference instructions, they are defined as when our D7 bit is 1 and I bit is 0. I means I am talking as the 15th bit and this D7 means I am talking as the 12, 13, 14, that is the opcode bit my. Then the register bit instruction, they are specified, suppose B0 to B11 bit of my IR address, here I am talking, and the execution it starts with timing signal T3, we have just seen in the previous slide. Here I am assuming I can write D7 I dash, because D7 is 1, I is 0, so I am writing it I dash, and T3 where my execution is starting. So, I am defining in short my register reference instruction as R, small r. So, next I will write the address of my IR, means IR address, it will be written as BI, where I will say ki this I can range, because it is an address. So, it will range from 0 to 11. So, the different examples of register reference instructions, they are being given as, suppose RB11, that is the clear accumulator, that is an instruction that tells ki RB11 will be the address. Here I can write the IR for this CLA. Then clear E, that is RB10. Then the next is complement accumulator, that is written as RB9. Similarly, I can write all these instructions for they are known as register reference instruction. Then the next is memory reference instruction. Memory reference instructions, they are identified when the effective address of the instruction is in AR and it was placed there during the timing signal T2 when my I was 0 or during timing signal T3 when my I was 1. When my I was 1 means I was using indirect addressing, and when my I was 0 I was using direct addressing mode. So, my T2 and T3 accordingly it will be changed. So, the memory cycle it is assumed very shorter enough to complete my CPU cycle, and the execution of memory reference instructions, they start with T4 if my I is 1. So, let us discuss the different examples of my memory reference instructions. Take the example AND. So, AND means I am performing the AND between one of the processor register, that is accumulator by default, and the second content will be the address register. I need to refer to that memory at the specified AR, means AR I am being given as one of the address where I will get the operand, here I will access that memory. So, AC accumulator and M of AR will be ANDed. At that time my opcode is defined as D0, means 000 in my control unit. Here this 000 is my 12, 13, 14th bit of my IR. Suppose this is my IR, this is my IR. So, these 12, 13, 14, 000 if I am getting from my 3:8 decoder output, that means my CU will be performing the AND operation. Similarly, if I am getting 001 from my 3:8 decoder, my CU will be performing the add operation. So, if add operation means AC plus M of AR and if there is a carry out, it will be taken into consideration and it will be saved into my E bit. Then the next memory reference instruction is the load the accumulator, means M of AR is accessed and the content of M of AR, they are being saved into accumulator. When I am having 0 1 0 as the output from my 3:8 decoder. Here we can clearly see that we are referring the memory as one of the operand. To get one of the operand, I am accessing memory. In the earlier slide, we can see we were accessing one of the processor register. One of the processor register, either it was accumulator, either it was E, either it was sequence counter or program counter. So, that is the reason they were known as the register reference instruction. Here I am accessing the memory, so they are known as the memory reference instruction. Similarly, I can store the content of accumulator at M of AR if it is D3, if it is D4, that means branch unconditionally, means AR, new AR is being given to me and this will be my PC now. If it is 101, that means branch and save address, PC is saved and I am getting the new. Then third type of instruction is my input output instructions. As the name specified, either there will be input instructions or output instructions, and we have discussed that the INPR and OUTR will be used, and these registers, they are being of 8 bits. Here I am giving the input through keyboard. This through keyboard, with the help of this transmitter interface, it will go into the input register. For one character, it will form the 8 bits, and the flag bit, this FGI, that is input flag, will be set as 1, and when this is processed, when this is given to accumulator parallelly, then it will be cleared to 0. Why is the requirement of this FGI? Because keyboard has different logic of working and CPU is an electronic device, it is an electromagnetic device. So, both has different speed and different kind of working. So, we require some interface so that they both can work together. So, when this will give this input will be processed, that means when this input is given to AC, this will be cleared, so that the keyboard can give the next input through transmitter interface. This transmitter interface works serially and it gives serially the value to INPR. Now, move on to the output part. From AC, the value is going on to the output registers, that is when the value of value from AC to output register is going, the flag FGO means output flag is set, and when this value goes to the printer through receiver interface, that is using a serial communication interface, this FGO has been cleared to 0, so that the next character, so the next value from accumulator to output device can come. So, in this manner this works, that means the terminal, it sends and receives the serial information, and the serial information from the keyboard, it is shifted to input register. The serial information for the printer, it is stored into the output register. Input and output register, we can see they can communicate with the terminal serially and they communicate with the accumulator in a parallel manner. So, the flags, they are needed to synchronize the timing difference between the input device and the computer. So, this was all about my different kinds of instructions, register reference instructions, memory reference instruction and input output reference instructions. Thank you.